Okay, class. Today your lesson is characteristics of relations and functions. Now we're going to talk about the different traits of various types of relations and functions. So first they're asking you to label each axis, label each quadrant, and indicate whether the coordinates would be positive or negative in each quadrant. So I'm going to give you a second to put what you think that'll be, and then we'll go over it together. You should have denoted this is your y and this is your x. And the quadrants go in order. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And these are usually written in Roman numerals. Now as far as the positive, positive, and negative, negative, starting in quadrant 1, you're going to have a positive, positive quadrant. In quadrant 2, you're going to have a negative and a positive quadrant. Quadrant 3 would be a negative and a negative quadrant. And then quadrant 4 would be a positive and a negative quadrant. Now the calculator check, don't worry about that yet. This is something we can look at later on in class. So now I want you to complete the table at the bottom and describe each given term. So for instance, on the first one, they're talking about the origin. Let's move the screen up just a little bit. So right now we're focusing on the origin. Where's the origin at? Correct, right there in the middle. Now give me a verbal description. Just take a moment and think about what you would call that. Now let's go to ordered pair. I'm going to tell you what I put in just a second. So ordered pair. What do you think an ordered pair is? Correct, it's just an X and a Y put together. So how would you put that as a verbal description? I'm going to go ahead and tell you what to write. Okay, see what my screen says now? For origin, we have the intersection of the x at 0 and the y at 0. Or the intersection of the x and y axis are the point 0, 0. For ordered pair, we have representation of the x and y coordinate point, the point x and y. Now what's very critical here, guys, and I want you to highlight when you write it on your screen, is I go over to x first and then I go up to y. So I go over left to right to x, then I go to y up and down. Okay, let's go to the next sheet here. Okay, on the next sheet, we have a couple of more vocabulary words we want to talk about. We have relation, domain, range, and function. And these are all words you're going to notice that are up on our word wall when you get to class tomorrow. So what we want is I want a representation, a drawing of what this is, and then I want a verbal description on what this can be. And I want you to take good notes here, guys, because you're going to use this to study for your vocabulary test. So by definition, we've talked about a relation. What is a relation? We talked about it being just a pairing of x and y. We talked about it being a set of points. We talked about it being a graph. So what I'm going to give you is a sample of that. I'm going to give you a sample. Yours don't have to look exactly like this, but I'm going to give you a sample, and I want you to write down this sample. Okay, so right now we're going to focus on the first one, which is relation. So go ahead and copy that down. A set of ordered pairs represented by a set of points, graphs, or an equation. A set of ordered pairs represented by a set of points, graph, or an equation. Then we have your domain. Now remember, your domain is all of your x coordinates. That's very important, guys. You're taking a test tomorrow, and you have to know your domain is your set of x coordinates. And it's also known as the independent variable. Something we talked about in class was that it's also the input value. So don't forget that as well. So just put a sample of what the domain would be. Like in this instance, I know that my 3, my 1, my -1, and my -3, those are my domains because those are my x's. That's correct. Now let's look at the range. Just like we denoted that the domain were all my set of x's, we have to denote that the range is all my set of y's. So I'm going to write down all of my y's, and those will be my range, which is my dependent variable or my output value. So then we're going to go on to function. If this is moving too fast, just remember you can pause it and go ahead and take good notes. So a function, what is the difference? What do you notice is the big difference between my relation and my function? My relation is drawn on its side. So it does appear that my x's are repeating, but is that still a relation? Yes. It does not pass a vertical test, but it's still a relation because a relationship does not always have to be functional. But when we look down here on function, you see that that has to pass the vertical line test because it has to be functional. It has to pass my vertical line test. My x's cannot repeat. So take a moment to jot those verbal descriptions down. Relation is in which each element of the domain is paired with exactly one element of the range. Set of points in which x values only occur one time. It's a graph where any vertical line will only cross the graph one time. Okay, let's go to the next page. You can always pause it if you need to. Okay, now on this page, we are at discrete. Let's make that screen just a little bit bigger for you there. Discrete. So remember, discrete means that it's not connected. You have like a scatter plot. You have individual points that are not connected. Make sure you understand that. So because I have discrete data, do I still have a domain and range? What will my domain be here? Correct. I would still say that my domain, I would just list them out. And remember, whenever you list them out, and this is just a hint for that test you're about to take, when I list them out, I'm going to put them in brackets. So I would put -1, 1, -3, and 3 as my domains. That's a set of brackets. Let me make that look a little bit better there. Okay, those would be my domains. That's just a hint for the test that you're about to take. Okay, so now let's look at continuous. Discrete data, points not connected. Continuous, infinite number of points that are connected. So I don't just have those points like I had above. Now I have a connection of those points. So make sure you understand the difference. So now, what's the difference between my domain? Would my domain simply be those points still? No, because this is continuous. It's gonna contain all these points, not just those points. For instance, it won't just contain let me go back. I'm not sure what I clicked on there, but let me fix that, guys. Okay, it won't just contain the -3 and the -1. Isn't there a -2 in between there? So it would contain that point as well. Does that make sense? It'll contain everything in between there. Okay, let's go to the next one. Now we have increasing. You're usually pretty good on this definition. It's when both the x and the y value have to both increase. Intervals to the graph when the function goes up left to right. So because I'm increasing left to right, that is considered an increase. Because I'm going up left to right is considered an increase. Whereas on the next one, as you can see, I'm going down left to right. I'm going down left to right. So that's considered a decrease. Go ahead and take a moment and jot down those verbal descriptions. Remember, those are really key to understanding. Okay, let's look at the next page. So here on page 4, they're asking you about function notation. And remember, a function is just a y. So this is where you're going to substitute a value to figure out what your y is. And this is exactly where we're going to stop, because this is where we're going to start in class. I hope you took good notes, and I hope as well that you went back and looked at N6-2 graphing quadratics, because that'll prepare you for your test tomorrow. Have a good evening.